Hello. In the second part of the lesson, we will look at ways to edit already created shaft sections. To edit any shaft section, simply double-click on its contour. Editing cylindrical sections allows you to change their sizes. To finish editing, press Escape. Let's try editing the conical end of the shaft. We'll double-click on it. In the dialog box, you can change parameters provided by the relevant DIN for this shaft end. For example, it can be shortened. Let's change it and see what happens. By clicking the Apply button, you can visually assess the changes based on the selected options. We'll leave all parameters as default and close the window. To edit the entire shaft, double-click the left mouse button on the axis of our shaft. In the dialog box that opens, the sequence of creating shaft segments is displayed. If we click on one of the shaft sections in the list, its outline will be highlighted in the graphics area. Also, using the shaft sections list, we can quickly edit their parameters. Click in the diameter field of the first shaft section and enter from the keyboard the value 45. When selecting a cell, you'll notice a button with 3 dots appearing. It allows you to set the desired size using measurement in the graphical area. For example, if we want to set the length of the first shaft section equal to the length of the second section, we simply measure it, and the length value of the first section will change. Let's return the length value back to 10. Also, using the editing window, we can add new elements to our shaft. Let's create spur pinion. To do this, go to the tooth wheel section, which is located at the bottom of the window. Among the elements that appear, select the spur pinion and specify the insertion point. Bring the cursor to the first shaft section. The section highlights in green, indicating automatic attachment of the gear to the shaft. Thus, the objects we create will be unified. Click the left mouse button to confirm the insertion point, and the spur gear dialog box will open. Specify the parameters of the spur gear. Set pitch equal for 2. Set the ring width of pinion, gear, to 40. Set the number of teeth to 24. Set the angle teeth, inclination to 12. Set the coefficient of displacement of initial operation contour of adjacent gear to 0.397, and complete the operation by clicking OK. After confirmation, the gear model will be created. While the gear creation command remains active, press the right mouse button or the Escape key. To the left of the gear, create 2 cylindrical shaft sections. For this, go to the Shaft Segments section and select the shaft from the proposed options. Create any 2 consecutive sections and press Escape. The sections we created appear at the top of the table. Let's edit their sizes. For the first one, set the length to 10 and diameter to 45. For the second, 20 and 40. In this window, by right-clicking on the created shaft section, we can add a new segment or, conversely, delete it. Also, change its type or open the editing window for the selected section. Let's add a chamfer to the last shaft section. Select the chamfer fillet element and apply it to the left end of our shaft. In the window that appears, leave the default value and click OK. Press Escape to finish the chamfer creation command and close the window for editing the shaft. In addition to directly creating shaft sections, we can create various dependencies between them. Let's create such a dependency between the diameter of the shaft end and the fitting diameter of the shaft for the bearing. For this, we'll call the Add Constraint function. It is located in the Library group. Expand the entire list by clicking on the arrow and select Add Constraint. Or we can use the command line, entering the beginning of the command nanoCAD and pressing Enter to confirm. In the window that opens, click on the cursor icon next to Child Object and select the contour of the seating shaft for the bearing. Then press the Parent Object button and select the contour of the shaft end in the model space. In both objects, open the parameters list and double-click to select the diameter. Press the bidirectional constraint button, then Apply. Thus, any change in one of these diameters will correspondingly change the other. You can learn more about the capabilities of the dependency management command in the help section. Close the help and press OK to complete the command. Let's try to change the diameter of the shaft. This concludes the second part of the second lesson. In the next part, we will cover the function of adding standard elements to our shaft. Thank you for your attention. When you're ready, move on to the next section.